I want to talk about testing batteries, and I've got some equipment here. So you can see this is my battery testing rig, and what I have here is the data from a previous test. So the way this works is I've tested many batteries, and these lines all show the various capacities. So in this case, it was a e-bike rental company. They have hundreds of e-bikes, and they don't know which batteries are good and which are bad. And they take people's money and they go out to enjoy the day on this rental bike, and it only goes a mile or two, and the person comes back and wants their money back. So they really need to find their good batteries and bad batteries. It's not readily apparent by just turning the battery on. So what I have here is the capacity of, I guess I probably tested 30 or more batteries for them and then wrote the capacity on them. So what we're doing today is we're going to test the capacity of an e-bike battery. Now there's a low-tech way to do this if you don't have this equipment, but I'm going to show the proper way to do it first, and then I'll show you the low-tech equipment next. So here I'm setting up my test, and I've set it to 14 cells, and here's my pack that I'm going to go ahead and test. This is a Lunicycles Mighty Mini, I think it's called. It's kind of a cool little screen on the front. It's upside down. Be ready to go. Now I have this on a pan in case this battery, sometimes batteries will catch on fire, so I have it on a pan and I'm ready to just dash outside and throw this in my barbecue pit, which sounds ridiculous, but these lithium batteries do at times ignite, and a heavy discharge test would be a time when that may happen. Okay, I hear the fans going. So what we have here are resistive loads, and we're seeing it's holding a nice steady voltage, and it'll start to drop. Mild warmth coming off of these, which is what's happening. The battery's discharging into the load, and then we're getting the data on the computer. Okay, the test is done. So it looks like we got 5.4 amp hours, which was 77% of what it was expected, 7 amp hours. And it took just over an hour, which is a good test rate. Now you can kind of see how the pack acted, and this is just where the BMS cut off. Now, this is an important number here, the test time. If I cranked up the amperage and tried to test this battery in 5 minutes, my measured capacity would be very different. So I like to do about an hour-long test. So there's our high-end test equipment. Let's go ahead and try the low-end test equipment and see how it compares. And just so you don't waste the time doing the test, go ahead and write the result on the battery pack. Okay, so here's our low-end test equipment. This piece of equipment, I'm going to plug this charger in, is I think about $8 or $10. So at this point we're going to go ahead and test how much the battery can hold when being charged. Basically same idea. We start empty, fill it all the way, and that'll tell us the capacity. Charger started, and we're going to see our amp hours tick up. Same idea, we're just counting the amp hours. So we'll wait till the charger finishes and goes green light, and then we'll check our measured amp hours. I'm going to talk about lithium battery safety. So if you're really not sure about a battery pack's state of health and you want to be as safe as possible, the best known safety procedure is to actually go ahead and place your battery in a barbecue and let it charge inside of a barbecue. This might sound a little ridiculous, but this could save the fire department coming for a whole bunch of smoke billowing out of your garage, or even worse, an actual fire started. So when I have a totally unknown battery, or I have reason to suspect it might have an issue, I'll go ahead and do my charging and discharging test initially within the barbecue. All right, so we went ahead and finished our test with this device and the charger, and we got a pretty similar result on the capacity for this battery. But it did show a bit more, and I want to show you why this device showed more than when I used the laptop. So let's imagine our battery is essentially a cup, and we want to measure how much this cup holds. That's our battery capacity. So what we're going to do first with the expensive laptop device, we would fill the battery completely, we would discharge, and then we'd have our device here, and this is our measurement. So we got 5.4 amp hours in this case. Now, while the battery's discharging, it got nice and warm. So there was some heat dissipation here. That heat happens before the measurement takes place. So basically there's some inefficiency in the battery chemistry itself. And that's fine because we want to know the usable capacity in the battery. So we want to take the heat into account. How much energy can we actually get out and use? That's the most useful number. Now in this case, with this device and the charger, we are starting with an empty battery, and we're going to go ahead and charge it. And we're going to measure here. So there's still heating that happens when we charge. So we end up with a kind of an erroneous reading that's a little high because we're measuring before the heating. So we're not taking into account the energy lost through heating. Now, it's still fairly accurate and a lot cheaper. There is a way to kind of basically have your cake and eat it too. If you want to use this cheap device, we could go ahead and do the discharge test, start with a full battery and discharge and use the cheap device, but we're going to need a load. So we have to, you know, if you have the battery, you have the charger. You don't need anything else except this $10 screen amp hour counter. If you want to get a little bit fancier, we can create a load, and the simplest, easiest load to set up is just a light bulb. So we could put, you know, the proper light bulbs in series to be able to discharge a 40 or 50 volt pack into it. And then we could use our amp hour counter, and we get a very accurate reading this way for not much money.